Quicker than the texture of spacetime itself, it can hold consciousness of it, and it will basically unwind. This is the kind of thing that fills me with fear. Right now, our evening time sky is moving rapidly, and in years and years, or perhaps even sooner, it could turn out to be very much unrecognizable. Astrophysicists are raising cautions, with specialists like Neil deGrasse Tyson affirming the undeniable impacts of Polaris. The story behind this shift is very amazing. Polaris, known as the North Star, has for quite some time been a constant in our night sky, filling in as a basic reference for cosmologists, pilots, and stargazers. Anyway, this could soon change, changing our perspective on the sky and the investigation of the universe. We should dive into the ramifications of this potential change. For a long time, Polaris has filled in as an aid for mariners and cosmologists, keeping a reliable position overhead as a guide. A constant presence has been crucial for navigation, yet that steadiness could soon be tested. In September 2023, an examination paper from the Royal Astronomical Society raised questions about the fate of this heavenly guide. Polaris is moving toward an unstable stage where it could detonate, potentially evaporating from the sky forever. Before we dig into the results of this potential event, we should first look more closely at the actual star. Polaris, or the North Star, is unique because of its proximity to the celestial North Pole, situated straight over Earth's northern pole. It appears almost fixed overhead. It dwells in the Ursa Minor star cluster, otherwise known as the Little Dipper. Polaris shines as a decently radiant yellow-white giant star, significantly larger and brighter than our Sun. However, Polaris is not a solitary star. It is part of a complex triple star system, with Polaris A and Polaris B as a binary pair, while a third star orbits them. The gravitational forces created by these stars shape their orbits and influence their behavior. Any disturbances in these interactions could result in fluctuations in the star's brightness or pulsation patterns. However, the specific nature of these forces is still not fully understood. Polaris lies around 323 light-years from Earth, meaning that the light we see from it today began its journey many years ago. Therefore, if Polaris were to explode now, we wouldn't see it for over 300 years. It's even possible that Polaris has already exploded, and we have yet to notice the light from that event. Since the beginning of time, the North Star has held social, navigational, and symbolic importance. Its consistent position made it a priceless guide for ancient mariners navigating oceans and terrains. Symbolically, Polaris has represented constancy and course, staying steady in the ever-changing night sky. For cosmologists, Polaris has been a key reference point, aiding the study of celestial development and variable stars. As a Cepheid variable star, its periodic brightness variations have provided valuable insights into cosmic properties and the nature of variable stars. This characteristic has also played a crucial role in determining vast distances and calibrating scientific instruments. These pulsations follow a predictable pattern, making the star's behavior easier to measure. However, recently, Polaris has strayed from this regular behavior. This anomaly in its pulsation cycle has intrigued astronomers, prompting a deeper investigation into this peculiar phenomenon. Rather than following its usual pattern, Polaris has begun exhibiting erratic dimming behavior, raising concerns that the star might be approaching the end of its life cycle. This is consistent with behaviors observed in stars nearing their death. The gradual increase in Polaris' pulsation period, which was once steady, can be attributed to interactions within its star system. There has been an annual increase of around 4.5 seconds in the pulsation length. While this may seem minor, it has significant implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be driving these changes in its atmospheric conditions, directly affecting its pulsation patterns. Others are more concerned that Polaris is approaching a critical stage that could lead to an explosion. The similarities between Polaris behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. The two stars have shown complex variations in brightness, raising concerns that they might be headed toward a dramatic explosion. Stars in their final stages often display such irregularities before they reach the end of their life cycles. NASA has expressed more concern about Betelgeuse, but formal attention has yet to be directed toward Polaris. As a Cepheid variable star nears the end of its life cycle, it undergoes several phases, including the red giant phase and, ultimately, the supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the stage of helium exhaustion, a common phase for giant stars nearing their end. These abnormalities in Polaris behavior align with patterns found in stars at the twilight of their life cycle. However, clear evidence of its impending supernova remains uncertain. Astronomers continue to monitor these irregularities to understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a monumental event in the sky, perhaps overshadowing the Moon and remaining visible for days, weeks, or even months. Its brilliance could dramatically alter our perception of prominent star clusters like the Big Dipper or Ursa Major, in which Polaris plays a central role. Rest assured, Earth would likely remain safe, whether or not Polaris detonates, given its size and distance from us. While a Polaris explosion may not be as visually spectacular as Betelgeuse's, it could still be visible to the naked eye for an extended period, eclipsing nearby stars. Astronomers and observatories would certainly take notice, sparking widespread interest within both the academic community and among stargazers. However, the impact on Earth's environment or climate would be less significant compared to a closer supernova event. But what will happen to Polaris itself? What will be its fate after a potential supernova explosion? Enormous stars regularly end their lives in a cosmic explosion blast. This isn't logical for Polaris. When a monstrous star goes through a cosmic explosion, it encounters a horrendous blast inside, denoting the last stage in its life. This interaction includes the total breakdown of the center, setting off a fierce shock wave that makes the star detonate. Anyway, Polaris isn't sufficiently gigantic to go through such an emotional blast. Rather, when Polaris depletes its atomic fuel, it will shed its external layers and progress into a white dwarf. This interaction won't bring about a cosmic explosion but will rather prompt a more quiet end as Polaris develops into a little, very thick heavenly leftover. A white dwarf is the thick center of a low to medium-mass star that has depleted its atomic fuel. This extraordinarily minimal star is generally the size of Earth but as massive as the Sun. Once this happens, we will never again notice Polaris as we see it today. Looking at the normal impacts of a Polaris blast with genuine cosmic explosion occasions gives significant bits of insight into the development of stars and their definitive destinies. Contrasting our assumptions and genuine cosmic explosion occasions, for example, SN 1987A and ensuing occasions like SN 2011FA and SN 2014J, gives crucial information for understanding what could befall Polaris in store. For example, SN 1354 prompted the development of the Crab Nebula, a cloud that continues to extend and transmit energy in different frequencies, furnishing cosmologists with a rich field for study. Also, SN 1987A, seen in the Large Magellanic Cloud, gave key bits of insight into nucleosynthesis patterns and the mechanics of cosmic explosion remnants, including peculiarities like cloud development and the release of high-energy jets and radiation. These insights can reveal understanding into the exceptional qualities of Polaris. The formation of nebulae like the Crab Nebula is a consequence of material delivered during a cosmic explosion blast that interacts with surrounding interstellar gas and dust, enriching it with heavy elements and adding to the cycle of star birth and death. Additionally, the release of high-energy particles and massive jets, rapidly pushed by cosmic explosion shockwaves, has implications for astrophysical processes and cosmic radiation. To make a conclusive comparison, researchers are looking at differences in the composition and speed of ejected materials between Polaris's potential blast and other observed cosmic explosion events. This includes studying light curves, spectra, and remnants from these events, and extrapolating similar characteristics for Polaris's expected blast. This will help us understand whether the blast of Polaris could lead to nebula formation or significant stellar circulations. Another significant area of study is the pulsational fluctuation of stars approaching their end stages. By contrasting Polaris with other cosmic explosion progenitors, scientists hope to gain insights into the mechanisms of stellar explosions. Pulsational variability in stars nearing the end of their lives might indicate internal instability or looming catastrophic events, providing valuable insights into the processes leading to cosmic explosion blasts. Despite careful observations and extensive research, space experts remain perplexed by the anomalies in Polaris's behavior. Understanding the circumstances driving these inconsistencies is vital for advancing our knowledge of stellar evolution. The study of the factors causing Polaris's erratic pulsations requires collaboration across multiple scientific disciplines and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a reference point in the night sky raises major questions for galactic exploration. Ground-based telescopes and astronomical measurements would need to be recalibrated, affecting the accuracy of celestial estimates. The absence of Polaris would also disrupt navigation systems and cultural practices based on celestial markers. Highlighting the significance of this event, the mysterious behavior exhibited by Polaris underscores the need for deeper investigations and dedicated research. Space experts must address the complexities surrounding its erratic pulsations and provide significant answers. Understanding the fate of Polaris is essential for advancing our knowledge of cosmic phenomena. The uncertain fate of Polaris challenges our understanding of the universe, but it also demonstrates humanity's enduring curiosity in unraveling celestial mysteries. The implications of Polaris's potential death stretch beyond cosmic interest. They reflect how humanity perceives its place in the universe. Since ancient times, celestial bodies have served as markers for time and navigation, helping to explore unknown terrains and waters. If Polaris were to vanish, it wouldn't just disrupt traditional navigation but could also significantly affect social beliefs and symbolism associated with the North Star in various cultures. Polaris has been fundamental to legends and spirituality. Native American tribes, for instance, saw Polaris as a guiding light, representing hope and freedom. Similarly, the ancient Egyptians used the North Star to align the pyramids with its position. The disappearance of such a prominent star could alter cultural narratives and shift the human experience surrounding navigation and direction. Moreover, the academic community would face significant challenges if Polaris were to disappear. Cosmic measurements and observations rely heavily on established reference points, and Polaris's consistent role has calibrated instruments and models used to study distant galaxies, stellar evolution, and even the expansion of the universe. Its sudden absence would require recalibrating many systems, potentially leading to errors in measurements and interpretations of cosmic phenomena. As astronomers direct their focus toward observing Polaris more closely, new observational advancements are being developed. Progresses in spectroscopy and photometry allow researchers to study the light emitted by stars in exceptional detail, enabling them to detect small variations in brightness that are crucial for understanding the forces driving stellar behavior. As scientists gather more data, they plan to refine their models of stellar evolution, especially concerning stars in their later life stages. The study of similar stars, like red giants, provides valuable insights for comparing their behavior to that of Polaris. By observing the behavior of such stars, astronomers hope to expand their understanding of stellar dynamics and evolution, furthering our knowledge of the universe's design. Additionally, with the growing focus on exoplanet discovery, the study of Polaris and its companions is becoming increasingly important. Understanding the properties of stars in triple systems can offer valuable insights into the formation and habitability of planets orbiting them. Astronomers are especially interested in how these stars influence their surroundings, as this could impact the conditions in which planets form and evolve.